Hey everyone, class number 34. We're doing some quiz 8 review. This is definitely isn't everything for the quiz, but it's definitely some of the bigger concepts or topics for the quiz. So looking at number 1 here, it says a 50-kilogram box is pulled along a rough surface at a constant velocity of 5 meters per second by a 350 Newton force. So first thing, let's get that free body diagram going. Let's see, so here is my box. So I have this 350 Newton force pulling forward. We're on a surface, so there's a normal force going up. As always, there's gravity pulling down. I kind of mixed them, getting ahead of myself here. That should be Fn, not Fg. Down we have Fg, right? And going back, we have our force of friction. How do we know there's a force of friction going back there? Because it is pointing to, because it's along a rough surface. Also, one of the later questions asks about it. You can make this force of friction negative right now if you'd like to. It doesn't really matter. Sure, make it negative. Doesn't really matter, but there we are. So why is the object in equilibrium? Big reason right here. Okay, it's in equilibrium because it is a constant velocity. That tells us a few things here. Constant velocity. Therefore, the acceleration equals 0 meters per second squared. Therefore, and I want to show you this, we know A equals F net over M. If A is equal to 0, net force has to be equal to 0 as well. Okay, so therefore the net force is equal to 0. And that's what equilibrium is, when the net force acting on an object is equal to 0. So the net force equaling 0 is another point here. All forces cancel. All right, all forces cancel. So think about it. This actually helps you out with C now. C, if all the forces cancel, okay, if all forces cancel, 350 newtons has to be equal to the force of friction. 350 forward, 350 backwards. Don't worry, get caught up with the positive and negative right now. Just understand that the force of friction is pointing the other way. Calculate the coefficient of friction between the box. Oh, we have to get the normal force actually. So listen about the normal force for a second. Okay, it's equal to the weight. Why? So if we look at this picture here, okay, we have to realize something. F net in the vertical direction, F net y is equal to 0. Therefore, all the forces have to cancel. All forces cancel. Okay, that's why the normal force equals the force of gravity. One thing I kind of brush over because it's actually not as heavily covered in Regents as you'd think. Really, we can only deal with the x direction or the y direction. So for part B, when I'm talking about constant velocity and that the acceleration is 0, what I should really be saying is that the acceleration in the x direction is 0 and the net force in the x direction is 0, and that all the x forces cancel. Just like here, I should be saying all the y forces cancel. Okay, so this should be x and this should be x. But again, the Regents exam doesn't go too crazy with that, so it's all right. So the normal force is equal to Fg, which is just mg, right? So normal force equals mg. Normal force equals 50 times 9.8, 490 newtons. And then for E, to get the coefficient, force of friction kinetic equals coefficient of kinetic friction times the normal force. Force of friction equals 350 newtons equals the coefficient of friction times 490 newtons. And we should get 0.71 equals our coefficient of kinetic friction. That is a unitless quantity. So let's just highlight our answers real quick. We have that one for E. There is our answer for D. Let's see, for B, we kind of explained it there. C, there's our answer. All right. All right, let's look at number 2. So we have a box that's 10 kilograms on an incline that's 15 degrees. It says the mass of, so as the angle of the incline is increased from 15 degrees to 30 degrees, the mass of the object will remain the same and the weight of the object will remain the same. Both of them will remain the same. Okay. Now, someone was asking about would the apparent weight change? If it's accelerating down, yes, the apparent weight would change, but the weight would not change at all. So the component of the weight parallel to the incline, so this is C, will go from blank to blank. So for C, that's going to be mg sine of theta. So we're going to have 10 times 9.8 times sine 15 and 10 times 9.8 times sine 30. This one comes out to be 49. I just kind of know that from doing it in my head. Let's check out this next one though. Okay, we have 25.4 here. All right, let's check out D. So this one's weight perpendicular. So we're talking about weight here, okay, for C and D, not acceleration. So it's mg cosine theta. So we're going to have 10, 9.8 cosine 15 degrees, 10, 9.8 cosine 30 degrees. So throwing these in our calculator. So this is going to be 94.7 newtons. And this one's going to be 84.9 newtons. And number 3. So we have a wooden box on a wooden floor. It's 30 kilograms. A 12 Newton force is applied to the box, but the box doesn't move. Why is the box at equilibrium? Well, it's not moving, right? Therefore, the acceleration is 0. Therefore, the net force is equal to 0. And it's equal to 0 x and y, right? It's not moving at all. So all the net forces are 0. So what is the force of static friction in this case? And why is it not equal to the coefficient of static friction times the normal force? So a lot of people would put that down, but remember here, the force of static friction is not always equal to this number. That's simply the threshold for motion, okay? So we know that the force of static friction will always equal the applied force until the object begins to move. So let's just draw a free body diagram for a letter B. I think it's a good thing to do. So we have 12 newtons pushing forward. It's not moving, right? We have a force of static friction holding it back. We have normal force, and we have Fg. Okay, since it is in equilibrium, okay, F net in all directions equals 0, x and y. That tells us that the normal force is going to be equal to Fg. That tells us that 12 newtons is going to be equal to the force of friction static. So it's actually our answer there for number B, or letter B. Okay, so what is the normal force acting on the box? Actually, we just kind of solved that, but we have to do some math. So the normal force we just said is equal to Fg. Don't forget, on Earth's surface, Fg can be replaced by mg. So the normal force equals, let's see, the mass is going to be 30 kilograms. And little g on Earth is going to be 9.8 meters per second squared, the acceleration due to gravity. So the normal force is equal to 294 newtons. All right, and the last one, how much force is required to start moving the box? That's where you're going to use that equation there. That's where you use force of static friction equals coefficient of static friction times the normal force. That's our unknown, 0.42, and normal force is 294 newtons. All right, so our force of static friction, the force required to start moving this thing. By the way, that coefficient is from the reference table. Make sure you know where to find that. We have 123.5 newtons required to start moving this thing. All right, Jay and Lee are sledding down hills on identical sleds. Jay has a mass of 70 kilograms, Lee has a mass of 90 kilograms. Explain who reaches the bottom first. This is equivalent to me saying I have a 70 kilogram ball and a 90 kilogram ball. I hold them up from the same height and I drop them at the same time. Which one's going to hit the ground first? Hopefully you know they hit the ground at the same time. Well, why do these two reach the bottom of the hill at the same time? So I'm going to write that same, nope, that. Same time. Okay, the reasoning. Acceleration down an incline is equal to g sine theta. Independent of mass. Independent of mass. And for this last one here, you are on an elevator on the first floor of a building. Your weight is 900 newtons. Explain how your apparent weight changes as you begin to move upward. So if you accelerate upward, apparent weight increases. As you travel upward at constant velocity, the acceleration is equal to 0. So apparent weight equals your actual weight. Which is 900 newtons. Here, your apparent weight would increase, so it would be greater than 900 newtons. As you slow down approaching the 10th floor, so if you slow down approaching the 10th floor, your acceleration is pointing downward, right? Because your velocity is decreasing as you go upward. So your apparent weight decreases. You feel a little bit lighter as you reach that top floor, less than 900 newtons. And as the elevator cable is cut, so in this point, your acceleration is pointing down, so it's definitely going to be less your apparent weight. But what happens is, since your acceleration is equal to g, apparent weight equals 0. You're weightless, okay? Do you actually have weight? Of course you still have weight, but apparently you're weightless. This is why people on the International Space Station float around, because they're continually falling towards the Earth. Why don't they hit the Earth? Because the space station is moving sideways so quickly that as they fall down, they also move over. So the Earth is kind of curving away from them as they fall. Okay, that's what orbit is. All right, folks, have a great day. Hopefully this helps you for the quiz. Remember, there are other topics that are going to be covered on the quiz. Just make sure you're good with everything. This should help you out quite a bit.